Hello everyone. Good morning students. Today we are discussing chapter number 7. The next topic is angular momentum in case of rotation about a fixed axis. As we have discussed in this chapter previously, what is angular momentum? Angular momentum is basically the cross product of position vector and linear momentum. L is equal to R cross B. If we will go for a system of particles, then we will sum up or we will take a vector sum of all the angular momenta of individual particles that will be given by L is equal to summation I equal to 1 to n Ri cross Pi. Now for a typical particle L is equal to R cross B, in the last section in the yesterday's video we have seen that when we will take a plane x dash y dash which is at situated distance OC from the main origin, then the position vector R can be given as OP, that will be equal to OC plus CP. This we have discussed in the last video. So, as we know that linear momentum P is equal to mv. So, you can say that L angular momentum can be written as R cross P. So, you can break R in two terms, OP cross mv plus CP cross mv. The magnitude of linear velocity v at a particular particle in terms of translatory motion is always perpendicular to the length cp or the perpendicular distance of p from the axis of rotation. Further, v is tangential at point p to the circle. You can see in the diagram here that v is in a perpendicular direction with the p. This is p. P के ऊपर जो पोजीशन वेक्टर है इससे V की जो डायरेक्शन होगी this will be the tangential. Linear velocity is basically V, and we know that at any curve, and how can we find out the linear velocity? By drawing a tangent at that particle. So, using the right hand thumb rule, we can see that CP cross V is parallel to the fixed axis, and the unit vector, we have taken the fixed axis as z cap, x and y is a plane of the paper, and we have taken the fixed axis as z axis. So the unit vector will be k cap. So how can you write the component of Cp cross mv? That will be equal to r perpendicular. Cp is basically position vector, and which is here the perpendicular distance from that. तो r perpendicular into mv क्रॉस प्रोडक्ट है, दोनों परपेंडिकुलर है तो साइन थीटा की वैल्यू 1 हो जाएगी, साइन 90 इक्वल टू 1 and k cap. So V is equal to omega r perpendicular. How can you write it here? M r perpendicular square omega k cap. Similarly, this is the Cp cross mv. Second term. Similarly, you can check the first term. It will become perpendicular to the fixed axis. तो हमने देखा यहाँ पर क्या कि जो हमारा Lz है ये तो हमारा सेम एक्सिस के अलोंग आया है, Cp क्रॉस mv वाला अलोंग द फिक्स एक्सिस, पैरेलल टू द फिक्स एक्सिस. सो फिक्स एक्सिस हमने z लिया था, तो उस फिक्स एक्सिस के अलोंग जो हमारा एंगुलर मोमेंटम का कंपोनेंट आएगा that will be Lz. So Lz can be written as Cp cross mv. It means mr square omega k cap. So the whole L can be, you can write it as Lz plus OC cross mv. We have written this term in terms of Lz. Now the next term is Lz is parallel to the fixed axis, but L is not parallel. But in general term, angular momentum L is not along the fixed axis. Lz is here fixed axis. For a particle, L and omega are not necessarily parallel. If we will relate this relation with translatory motion, then P and V are always parallel to each other, because the formula for linear momentum is basically m into V. M is a scalar quantity while V is a vector quantity. So the resultant direction of P will be parallel to velocity vector. So if you will take that for the system of particle, then capital L can be written as Li, I for ith particle. You can write it here Liz plus OCI into Mi cross Vi. Now L perpendicular and Lz are the components of L, because Lz is along the main axis and L perpendicular is in the plane of the paper, which is in the x dash y dash plane. and that will be perpendicular to the axis of rotation. So you can write it here L perpendicular. So L perpendicular का component कितना आएगा बेटा? जो ये आपका बच गया है OC into MV, ith component के लिए लेके चल रहे तो OCI into MIVI. अब अगर हम LZ की बात करते हैं तो that will be MI/RI square omega k cap, and you know that M into R square, this is the basic formula for the moment of inertia, so you can write it here I omega k cap. So LZ is basically equal to I omega k cap. This is the same thing which I have told you. Now L will be equal to LZ plus L perpendicular. LZ is I omega k cap and L perpendicular is in the plane X and Y dash. Now if we will go for the symmetric body, mostly the bodies are symmetric, like we have taken disc, thin rod, sphere, all the body which generally we take are symmetric about the axis of rotation. That is, axis of rotation is one of their symmetry axis. For such bodies, OCI, for every particle, there will be a component of velocity in one direction from the origin, while diametrically opposite direction में उसका another component minus vi locate करेगा diametrically opposite direction में. So उस केस में हमारा जो L का perpendicular component होगा that will term 0, because mi into vi वहाँ पर 0 हो जाएगा. एक positive है, एक diametrically opposite है तो वो negative हो जाएगा. That will give you L perpendicular is 0. So the resultant L will be equal to only LZ, and LZ we have find out I into omega. So you can write it here LZ is equal to I omega k cap. Now if you will go for the differentiation of LZ with respect to time, then d by dt of LZ is equal to d by dt of I omega k cap, and you know that dl by dt is equal to basically torque. So if we will go for the component of torque which is parallel to the axis of rotation, then you can write it here tau is equal to tau k cap and L is equal to LZ plus L perpendicular. L perpendicular की डायरेक्शन में तो हमारा उसका component क्या हो जाएगा tau का, that will be 0 because that is the perpendicular and that will lie in the x dash y dash plane, that is the plane of paper. So dLZ upon dt will be equal to tau. It will, the parallel component will follow this relation, but the perpendicular component will be 0. So you can see from here the differentiation of any quantity is 0. It means that quantity is constant. So you can see that L perpendicular is constant. Now d by dt of I omega, that will be equal to torque, because from here you can see that d by dt of LZ is equal to tau and d by dt of I omega k cap, that will be equal to tau k cap. So you can see d by dt of I omega, that will be equal to tau, and I is constant with respect to t, so you can write it here I d by dt of omega, and d by dt of omega will term as alpha, that is angular acceleration. So you can see that tau is equal to I alpha. So this is the equation for work energy, work kinetic energy in terms of rotation. Okay beta, tomorrow we will discuss a next topic, rolling motion. Thank you बच्चे, God bless you.